Don't look at this particular table at this point of time, since I am going to draw the landing wall, riser, isometric. Then we can easily discuss about these particular points. So now we are going to draw the landing wall riser or the standpipe riser, which is connected to the number of landing valves. Fine. So this will be landing valves. I'm just representing LV for this particular thing. So for example, you have 1, 2, 3, 4, 5 floors, or we can make it as 6 floors. So 6th floor and 5th floor will be 250 GPM. We need to consider, since as I already told, the two remotest landing valves shall be considered for calculations. But in our case, we have one more standpipe which is also installed till 6th floor in some other staircase. So for this also we need to consider 250 GPM. If you've gone through my previous slides, you will understand about this particular thing. Now what I will do, I'll put some gate wall and check wall, and this will be our starting node. So I'll put some node numbers. For example, we will put like this will be like 1. I will take one more color. So yeah, this will be node 1, node 2, node 3. Since we are concentrating on these two remotest valves, so till here we are going to put the nodes, and then what we'll do, we'll come to here. This will be 5 and this will be 4th node. Fine. And here it will be 6th node. So total we have 6 nodes. We are not going to consider nodes for this because this is not required. Okay, it will be a lengthy process if we consider this also, these points also. If you want to know what is the pressure available, for example, at this particular landing wall, then you need to put node here also. So basically for your for explanation, I'm just considering the nodes for this particular point 2 and point 3, and then finally I am coming to the 5th node and till the 6th node. So our hydraulic calculation procedure will be done based on these nodes only. These nodes are enough. However, if you want to know what is the pressure available at, for example, this is the first floor or ground floor, then you need to put nodes in each connections. Anyhow, so just we'll move on. You can see here on your screen, here we have node 1, node 2, elevation 1, elevation 2 in feet, K factor, flow added this step small q, total flow capital Q will be in GPM, gallons per minute, nominal ID, actual ID of the pipe, fittings quantity and equivalent length, LFT in feet, L means length of the pipe, F means fitting equivalent length, and T means total length of the pipe plus fitting length. C factor and pressure per foot. PT will be the total pressure, PE will be the elevation pressure, PF will be the friction pressure. Here I mentioned some notes and remarks. There are 5 steps to perform this particular calculation. So here if you see, we have 1, 2 node. So I mentioned here 1, 2, and then 2, 3. I mentioned it here, and then from 3 to 5, here you can see 3 to 5 I mentioned. Starting node will be 3 and the end node will be 5. and from 4 to 5 is also a node. So 4 to 5 I mentioned it here, and from 5 to 6 I mentioned the same beginning node as 5 and end node as 6, but actually this 6 will be the starting node. So basically we will perform the hydraulic calculations by considering the node numbers from the remotest area, so that it is easy for us to perform the calculations. You can mention like this point as 1, 2, 3, 4, 5, 6 as your wish, but for my you know for my understanding, I think this is the better choice to put the nodes. So here we have elevation. I did not tell you about the elevation. See, for example, this is 0 node. So 0 elevation will be the starting reference, will be 0 only. So the last landing wall is at 45 feet from the 0 reference. So it means, see, we are considering this particular point as 0 elevation. So this total height is 45 feet, and consider like this 5th floor to 6th floor, it will be 10 feet height. So with these details we can do the calculations. So now coming back to our particular point, before we move ahead, if you want to know the hydraulic calculation procedure for the sprinkler system, you can watch my video which is already available on my YouTube channel, and the topic name is hydraulic calculations for sprinkler systems. You can search on my YouTube channel Irfan CFPS. So coming back to our particular topic here, the elevation one is at 45 feet. So see, our first point is at 45 feet from 0 level. So 45 I mentioned, and elevation 2 will be the second elevation, second point. Where is this node? 2 is also on the same elevation, so we have mentioned 45. Small q, since for 2.5-inch hose valves we need 250 GPM, so I mentioned 250 GPM is our requirement. And then nominal ID, this size of this 1 to 2 node will be 2.5-inch, since we are going to consider 2.5-inch hose valve. So I mentioned 2.5-inch, 2.5-inch, and the ID internal diameter, you can check the catalog of black steel pipe, since we are considering black steel pipes here, schedule 40. So actual ID will be 2.47. Fine. So now here we have fittings quantity and equivalent length, because from 1 to 2 node we have landing valve or hose valve. Apart from that we have elbow. Fine. If the line extends till the air vent, then we will consider this as T. So I consider here as T. This 12 feet how we got, you just check my video on friction loss calculations, and also you can go through NFPA 14 for equivalent fitting length chart, which gives the equivalent length for fittings like T, elbow, cross, and so on. Apart from that, for the angle hose valves also, NFPA 14 says equivalent length will be 31 feet. You can check NFPA 14. So length of the pipe, so 1 to 2 will be 1 feet I consider. I did not mention it here, but it is 1 feet. And fittings equivalent length will be 43, because angle valve equivalent length plus T equivalent length we get 43 feet. So L plus F we are going to get about 44 feet. So C factor for black steel wet pipes is 120. If you are considering any other pipes like PVC pipe or HDPE pipe, the C factor will be different. You have to check NFPA 13 for C factor, or if you have dry pipe, the C factor is different. So you just check my video series on friction loss calculations to know more about the C factor concept and also pressure losses or Hazen-Williams formula. So basically friction loss we need to calculate from this particular 1 to 2 node. So for 1 to 2 node there is formula, I did not mention it here, you just check NFPA 13 or my video series on friction loss calculation. So based on that formula we got 0.215. So now here, since our requirement for the first node or the first landing wall is 100 psi, I mention it here 100 psi. Now elevation, because elevation 1 to 2 is on same elevation, so there is no change in the elevation, so we will put 0, and the friction loss or total friction loss will be 44 multiplied by 0.215, which will be about 9.46. Then we will add 100 plus 0 plus 9.46, we are going to get 109.46. So if we require 100 psi here, at node 2 we need to have 109.46 pressure, then only we will achieve 100 psi pressure at this particular landing wall. On, you can see on right hand side I mentioned nodes, you can go through this so that you will able to understand. And then once we got the pressure required at node 2, then I'll go back to node 3, I mean 2 to 3. The distance will be 10 feet. So here you can see 2 elevation will be at 45 feet, and for 3 node 3 the elevation is at 35 feet. So basically here this Q, because at 2 there is no flow or there is no outlet, so we just mention as 0, but this Q will be, we need to add the above capital Q plus small q. So 250 plus 0, it will be about 250 only. Fine. And then here we are going to consider from 2 to 3, 3 to 5, 3 to 5, yeah. 2 to 3 and 3 to 5 will consider 4-inch pipe, and from 5 to 6 we will consider 6-inch pipe, and from 4 to 5 we will consider 4-inch pipe only. So here you can see nominal ID 4-inch for 2 to 3 node, and ID will be 4.03, and we did not consider any fitting, so none I mentioned. Length of the pipe will be 2 to 3 node will be 10 feet. Fine. Fittings 0, since we don't consider any fitting. If we are considering any fitting, we need to add here. So 10 plus 0 will be 10, total 10 feet. C factor, since the pipe is black steel only, wet steel 120, and this 0.02 from friction loss formula we got, considering 4-inch pipe size. And here if you see this PT, total pressure will be 109.46, which we already got above, so this will be the same. And elevation pressure, we have formula 0.433 multiplied by length of the pipe. Here elevation length will be 10 feet, so for 0.433 multiplied by 10 feet is equal to 4.33 feet. So I mentioned here. And PF, friction loss, will be 10 multiplied by 0.02 will be 0.2. Then we will add all these things, we will get 113.99 psi. So in order to achieve this 100 psi at the remotest landing wall, we need to have 109.46 at node 2 and 113.99 psi at node 3. Now similarly you need to check for 3 to 5. Here 35 elevation for 3 will be 35, for 5 we consider as 0 elevation, for 5, 6 we considering as 0 elevation only, so I mentioned that one. So here we have 250 GPM. How I consider this 250? Because at third node also we need to have 250 GPM, so that's why I am considering 250 GPM. So I mentioned 250 GPM. At 5 it will be combination of the above Q plus small q. So 250 plus 250 I am going to get 500 GPM. Here also the pipe size will be same, 4-inch. Here I have elbow. I consider this particular elbow here, and this 10 feet from the equivalent length chart. You can check NFPA 24 length of the node 3 to 5. From 3 to 5 I consider as 285 feet, and F will be 10 feet for elbow. T will be total 285 plus 10, it will be 295. C factor will be 120, and from friction loss formula based on 4-inch pipe I am getting 0.07, and then finally here total pressure will be 113.99 plus elevation pressure, this is the formula 15.15 I got, and friction pressure 295 multiplied by 0.07, it will be 20.65. so I am getting 149.79 at fifth node. So now I consider 4 to 5 as well. If you see here similarly, but I am getting from 4 to 5 120.55. The pressure required to reach this particular point, I need 120 psi only, but because this is the remotest landing valve, not this one, so to reach 100 psi at this particular point I need at node 5 149.79 psi. So I am ignoring this 120.155, because if I have 149.79 here, it means I have 120 also. So I am going to ignore this 4 to 5 node as well. From 5 to 6 I am considering this 149.79 requirement, and elevation pressure 0, PF will be 35.1. So I am going to get about 184.89. so here we can consider 4-inch or 6-inch. Just put 6-inch and check how much you are getting the friction loss by using friction loss formula. I mentioned I believe 4-inch here, so based on that I got 0.15. so if you add 149.79 plus 0 plus 35.1, I am getting 184.89. it means at starting node I need to have 185 psi so that my water will reach to this landing valve and we will get our required pressure 100 psi. So in other words, if I say in order to reach our water to this particular point with 100 psi pressure, we need to have 185 psi at starting node. So based on this hydraulic calculation, we got 185 psi requirement at the starting node, and the capacity or the flow required or the demand required will be, since we have two standpipes, we consider 250 plus 250 plus 250, so 750 GPM. So 750 GPM at 185 psi will be the pump requirement or pump capacity. Or if you have sprinkler systems, then the pump capacity we need to see whether this is the higher demand or the demand from the sprinkler is higher. Mostly this will be the higher demand, but we need to check about the head also. So finally, in order to conclude, I say our requirement is 750 GPM at 185 psi. But please note, if you have any query, just let me know, because you cannot just perform the calculations as you like, because there are a lot of complications which you'll be able to know through experience only. So if you don't have this particular riser, then you just consider 250 and 250 and run the calculations. So it will be about 500 GPM only. Fine. I hope you understand the concept of this hydraulic calculation procedure. And just if you are really happy with my video series, please do like, share and subscribe, and share it with your friends as well, so that they will benefit from my video series and you believe in yourself, so that you will reach to higher levels. Thank you once again. Bye.